Okay, so let's go ahead and take a look at this lesson. So this lesson is a little unique, and that is we have x's and n's as variables in our series. And so the goal of this lesson, so anytime you see a series that has both x's and n's involved, what you're going to try to do is you're going to try to find either the interval of convergence or the radius of convergence. Interval convergence takes a little bit more time if you don't have a geometric series, because you have to test the endpoints to see whether or not your interval can be less than or equal to or just less than. So that's where it gets a little crazy. But with your interval of convergence and radius of convergence, what you're trying to do is you're trying to force convergence. So you're trying to see what values of x, when I plug it into the series, would actually make a convergent series. And so that's what your goal is. Radius of convergence, finding the radius of convergence is slightly easier because you don't have to evaluate that absolute value. But in the end, I do want to show you guys, you have to remember some things about evaluating absolute value inequalities as well with this particular section. Okay, so I want to find the interval of convergence. I have nth powers, so I'm going to use the ratio test. So the limit n approaches infinity, 3x minus 2 to the n plus 1 divided by n plus 1 times invert and multiply your original equation to the n power. I'm going to rewrite this now. Limit n approaches infinity, 3x minus 2 to the n power, 3x minus 2 to the first power, all divided by n plus 1 times n over 3x minus 2 to the n power. So what I notice is that my 3x minus 2 to the n powers cancel out. So what I'm left with, limit as n approaches infinity, 3x minus 2 times n over n plus 1. This 3x minus 2 has nothing to do with this limit because this limit only involves n. So I can pull it out, and I should have put absolute value around here. So I can pull it out, absolute value 3x minus 2, limit, n approaches infinity, n over n plus 1. This limit goes to 1. So then I have the absolute value of 3x minus 2 times 1. Now, in order for this ratio test to converge, I have to force this to be less than 1. Greater than 1 is divergent, and equal to 1 is inconclusive. So then I want the absolute value of 3x minus 2 to be less than 1. So negative 1 less than 3x minus 2, which is less than 1. Probably should have put that down here. Okay, so then I can solve. So negative 1 less than 3x minus 2 less than 1. So add 2 to everybody. So I get 1 less than 3x, which is less than 3. Divide everybody by 3. And then I get 1/3 is less than x, which is less than 1. I have to test to see whether or not I can be equal to 1/3 or equal to 1. So I have to do what's called checking the endpoints. What that means is that I have to take both the 1/3 and plug it in for x up here, do a test for convergence. And then I have to do the exact same thing, but plug in 1 in for this x and do another test. So this is where it's kind of a pain, because you're going to do all this work and you could do all this work for nothing because it could be just divergent. So I would say this, on a free response test, what I would do is once you get here, I would say, you're only going to get another point for testing the endpoints. You might get a pity point for attempting to test the endpoints but doing it wrong. So what I would probably do is I would probably say something like, testing the endpoints, x equals 1/3, plug in the 1/3 and just write either convergent or divergent. Do the exact same thing with 1, say either convergent or divergent, just make a guess, and then go back later if you have time and actually test the endpoints for real, if you have nothing else better to do. So I'm going to test the endpoints here. So I plugged in my 1/3 here in for my x, and then I simplified. So I got -1 to the n power over n. This is an alternating series because of the alternating part here. So I do the test. Plug in 1, plug in 2 in for n, plug in 3 in for n, and also that limit goes to 0. So it is convergent at 1/3. All that means is that I can put a little equal bar underneath the inequality sign. Then I do it for 1. So I plug in 1 in for my x, and I get 1 over n. This is a p series where p is equal to 1. We call that a divergent harmonic series. So I cannot put an equal bar underneath 1. So therefore, my interval of convergence is this. Okay. Now, if you had already found your interval of convergence and they asked you to find the radius of convergence, you find the center point in the interval, and the distance from the center to one of the outermost regions is your radius of convergence. Typically, they don't have you do it after you've already found the interval of convergence. Typically, they do it when you're at this step here of your absolute value of 3x minus 2 is less than 1. So in order to do this, and to find your radius of convergence, what you do is you have to get the coefficient of x to be 1 and not 3. So I factor a 3 out. When you factor a 3 out of 2, it gives you 2/3. So your radius of convergence is 1/3. Your midpoint of the interval is actually 2/3, which means that from 2/3, you can go to the right by 1/3 and to the left by 1/3, and you would actually get your interval of convergence. Okay? And that is it for this lesson.